BSc Today's session agenda will be talking about cloud computing and Google Cloud Platform. Um, Slide, please. Change the slide. What is cloud computing? Cloud computing is a type of computing that uses a network of remote servers hosted on the internet to store, manage, and process data than a local server or a personal computer. The model of computing allows business and individuals to access a wide variety of applications and services through the internet, including storage, network analytics, AI, and much more. In a technical sense, cloud computing involves the use of a virtualized resources such as virtual machines, storage, and networking to deliver services over the internet. These virtualized resources are managed by a cloud provider like GCP, which is responsible for maintaining the infrastructure and ensuring that it is always available and scalable to meet the needs of the users. Fundamental characteristics. Talking about fundamental characteristics, these include on-demand, self-service, broad network access, access control pooling, rapid elasticity, and measured service. These characteristics enables user to access and use cloud computing services quickly and easily without need to manage and maintain complex structure. On-demand self-service, this refers to the ability of users to access and use cloud computing services without the need of human intervention from the provider. Users can sign up for and use these cloud services on their own without having to wait for approval or assistance from the provider itself. In broad network access, cloud computing services are accessible over the internet. So, like using a variety of devices and network, this enables users to access their data and applications from anywhere, using a device, any kind of device from any time. Cloud providers typically operate and use large data centers, which they use to provide um, computing resources to multiple users. These resources are pooled together and allocated to resources on as needed basis. So this enables users to access the computing power they need when they need it. Cloud computing services are designed to be highly scalable, allowing users to quickly and easily increase or decrease the amount of computing resources they use. This enables users to respond to changing demands and workloads without the need to invest in additional hardware or infrastructure. In measured service, cloud providers typically monitor and measure the use of their services by their users, providing detailed billing and reported information. This enables users to track and control the spending on cloud services and help the providers to optimize the use of their resources. Now let's talk about the models of cloud computing. There are mostly three main models that are infrastructure as a service, platform as a service, and software as a service. Infrastructure as a service, or IaaS, is the most basic form of cloud computing, where the provider offers access to fundamental computing resources, such as servers, storage, and networking over the internet. Users can use these resources to build and run their own applications and services. Platform as a service is a higher level form of cloud computing when the provider offers a pre-built platform for developing and deploying applications and services. The platform typically includes operating systems, database, middlewares, and many more other tools that are needed to build and run applications. Software as a service is the most advanced form of cloud computing, where the provider offers access to a complete software application or a suite of applications over the internet. Users can then use these applications on demand without the need to install or maintain them on their own local systems. Talking about Google Cloud Platform, it is a suite of cloud computing services offered by Google. It includes a range of services for computing, storage, networking, and other needs. And it is designed to help businesses and organizations build and run applications and services on the cloud. GCP offers a variety of features and tools, including support for popular programming languages and frameworks, access to powerful data analytics and machine learning tools, and integration with other Google services such as Google Maps or Google Drive. There are a lot of services provided by GCP. Google Cloud provides a wide range of services for business developers and organizations so that they can build, deploy, and manage applications and infrastructure on the cloud. Some of the services provided by Google Cloud are compute services, which includes services for computing, including like Google Compute Engine for running virtual instances or machines, Kubernetes engine for deploying and managing containerized applications, and App Engine for building and deploying web applications. Now, storage includes services for storing and managing data, including cloud storage, which is used for cloud storage for storing those data, BigQuery for analyzing large data sets, and Cloud File Store for storing and accessing file-based data. Along with that, we also have Cloud Bigtable for storing and managing large data sets, Cloud SQL for managing relational databases, and Cloud Firestore for storing and syncing data in real time. In artificial intelligence and machine learning, these include services for building and deploying AI and machine learning models, including Cloud AI Platform for training and deploying machine learning models, Cloud AutoML for automating the process of training machine learning, and Cloud Natural Language for understanding and extracting information from text. Next slide, please. There are mostly four ways to interact with GCP. First one is using GCP console. This is a web-based interface that lets you use a GUI or graphical user interface to manage your GCP resources. It gives you a central place to create, configure, and manage your GCP resources, as well as place to see how your resources are doing and how to use them and get different tools and services. Next slide, please. This is how your GCP panel will look like. Now, moving on, we have something called Google Cloud SDK, which is a set of tools that are used to manage your resources and applications of GCP. One of these is G-Cloud tool, which is a GCP's main command line interface for its products and services. Another example is also GSUtil, which is used for cloud storage and BigQuery. Cloud Shell is an easy-to-use browser-based command line interface for GCP. You can use tools in Google Cloud SDK while interacting with GCP using Cloud Shell without having to install them first. Now, it acts like a DOS environment where you can deploy an app, access your app, and perform various powerful functions on the GCP. It is the most powerful way to interact with GCP. When you click on the terminal in the GCP console, you'll get to know this console where you can use all the SDK tools provided by Google Cloud. Like these. Using REST API. Now, GCP gives you a set of REST APIs that lets you use and manage your GCP resources and services through code, be it any programming language that can send HTTP requests and read JSON responses to get to these APIs. You can turn APIs on and off using the GCP console. A lot of APIs of these APIs are turned off by default, and a lot of them have quotas and limits. You can only turn on the APIs you need, and you can ask for the quotas to be raised if you need more resources. This keeps you from accidentally using resources and reduce your billing. For example, if you're making an app that needs to control, let's say, GCP resources, so you'll need to know how to use the APIs correctly. And to do that, the GCP console has a tool called the API Explorer that lets you learn about APIs in an interactive way. It shows you what APIs are available and what versions they come in. Using the mobile app, this is one more tool that is of interest to everyone and not just developers only. Sorry. With the Google Cloud Console app for Android and iOS, you can look at and manage a lot of GCP resources you're using. It lets you make dashboards that shows you all the information you need at a glance. You can customize it accordingly. Next slide, please. They're using GCP. GCP allows you to easily scale up or scale down your application based on the computing power it needs without the need to invest in additional hardware. GCP offers a wide variety of services so that you can choose from the ones that best fits your application needs. GCP follows industry-leading security practices and has multiple layers of security to protect your data. It has a global network of data centers, so you can choose the location that provides you the best performance for your target users. It provides a pay-as-you-go pricing, so you only pay for the resources that you use. And its integration with Google products provides your organization to use other Google products such as G Suite or Google Maps or Google Drive. GCP can easily integrate with these tools. And as a leader in cloud computing, GCP is constantly innovating and adding new features and services to its platform. Now, let's have a hands-on experience with how to set up load balancers and everything. Um, I'll just share my screen. So uh, this is your Google Cloud TCP panel, how it's supposed to look like. Uh, we will agree to that. So first of all, you might wonder what are load balancers and how to set it up on um, GCP. So load balance, whenever you create a request to a server, there's a load balancer which proxies the proxies the request to multiple servers depending on how much traffic is being there. So there are several ways to set up load balancers. I'll show you how to set up a network load balancer. First, we will go to our project, or we can create one. In this case, it is this particular one. Then we can open a Cloud Shell. We can use for setting up load balancers. First, we will need to create some web servers. For that, we will use Compute Engine and install Apache on it, and add a firewall rule that allows HTTP traffic to react to that instance. You will need to either use the GCP console. You can create a instance from the Compute Engine VM instances, or you can use the Cloud Shell to do this. For example, I'll just use the Cloud Shell. Let's first activate the Google Cloud Shell environment and configure default compute zone. In my case, it's yeah. So we do gcloud config set compute zone. We can change the, let's say we want to do US or something. We can change it accordingly. What this command will do, gcloud compute instance create ww1. It will create a compute instance, a VM instance, which is named www1, and we can specify the zone accordingly. Then we can tag it. Let's say I want to tag it. Tags are used for grouping, which will be useful in setting up load balances. In once we are uh, once we are setting up load balancer, we can tag the server so that we don't have to remember the exact ID of it. So let's say I want to tag a network LB tag. It used to identify our server in future, and then machine type equals to EC2 small. Um, there are a lot of machine types that are involved in GCP in the compute instance as a template. So in this particular one, we are specifying the machine type as E2 small, which will which will create a 2 GB 2 GB memory and 2 vCPU server, which is decently small size and but very powerful for our server in this. Image family specifies a group of images that are based on the same operating system. In our case, it's Debian. So this will ensure that we get the latest patches and security fixes, and it's regularly updated. Image project we are choosing as Debian Cloud, which is basically a public project that provides pre-built images for various versions of the Debian-based operating system. We can also specify a metadata. Let's say it's a startup script, so that whenever the instance starts, that particular script will run. So in our case, we will want a script that runs and installs Apache 2 web server and hosts a website on it. Apt get update to get all the updates from server. Apt install Apache 2. It will install the Apache 2 web server, and then we can use service Apache to restart the server. Now we will want to uh, save a HTML file, let's say web server www1. So when we go to the particular address, we will be able to identify that our web server is indeed www. We'll save it at var www html. Now what this will do is it will ensure that the file where it says it's web server www1, it will save it as index.js in that particular location. Wait a second. Oh, I might have made a mistake here. Let me fix it. Instead of instances, we had to use instance. Hmm. We did a syntax mistake at here, so it's fixed now. So now it will create www a compute instance of machine type E2 small, which is again a wait. We didn't authorize it. Okay, we'll just authorize it. So give me a second. If it does it sometime, let's just redo the cloud shell. There might be some authentication error right now. Yeah, should be fine now. Let's just check if it's showing our project. Oh, amazing. It shows our project. So it's authorized now. Now we can go with changing the compute zone. Let's say we are doing US West B for now. And as I did before, we'll create a compute instance saying www1 and which creates a Apache server. So I'll just have the command here, which I'll just paste again because um, now we can see that it gave us a success error. And like if you want to check, we can just check here that yes, it has uh, our instance www1 is running. Now, what you want to do is we might want to repeat the same thing again so that we create another instance of it with the same Apache server. But this time we'll create a different HTML file so that we can identify the server. So here we are creating a www2 instance and we are specifying the web server being www2. And it says here instance is running. So it has successfully created a new server. We'll repeat the same for just clear the console. Repeat the same for a www3 machine. Now we can confirm that it's created. Let's just, yeah, you can see on the GCP console that it's created. Now what we want to do is now what we want to do is we need to create a firewall rule so that all the incoming TCP traffics is allowed on that particular tag which we grouped it. So we grouped them as network LB tag, if you remember. So we'll allow port 80 extra so that on that particular port, external traffic is allowed by a different network. So like it is internal and external networking. So our command will be cloud create firewall rules. Wait, cloud compute because we are dealing with create www firewall network. This is the name of the firewall rule, and then we'll target the particular tag, which is network LB tag, and we'll pass in a allow TCP 80. So now it shows that it has successfully done it. So like we can also verify that the running they're running by checking the IP address of the instances. To do that, we'll do compute. Let's see cloud compute. We can either like directly go from here. Let's say this one. It shows at our web server is www1. Let's check second one www2 so that we can confirm that yes, the firewall has successfully applied. Now let's create a HTTP health check, which will basically monitor the status of our server by sending periodic HTTP requests to a specified URL, in which case will be the external IP. Yes. So let's first create a load balancing service first. So addresses. For that, first we'll have to create a static address. Our region is US West. Um, so it's successfully created. Now we can create a health check, uh, uh, a HTTP health check. We'll call it basic check. So gcloud compute So we can see that it's successfully created, and now we'll create a target pool. So that it basically what a target pool is, a collection of instances that can receive traffic from load balancers. It is used to distribute traffic across a group of instances. So let's do that. In this, we are creating a target pool with the name www pool, and we specify the name with the instances in a basic set. Basic set. The error in the name. It doesn't matter. So sorry about this. Now we have successfully created a target pool with the name www pool, which is on the region US West 3. Now we will add those instances that we created in the initial setup of load balancer to our target pool, which are www1, www2, www2. We'll have to configure a forwarding rule first. Now it is used to bind, what is a forwarding rule? Basically, it's used to bind a load balancer to a target pool and specify the protocol and port range that the load balancer has should use to distribute the traffic. So in our case, it would be gcloud complete compute forwarding rules create www. We'll specify a port range as 80 so that load balancers should only accept traffic from that particular port. Specify the external static IP that we created to be used by the load balancer. In our case, we tagged it as we created the name as network LB IP1, so that we'll distribute the traffic over that. And then we also added a target pool with our particular instance. So pool being www pool. As it shows, we have successfully created the forwarding rule. Now we have to configure the load balancing service. We have actually successfully configured the load balancing service. We can now start sending traffic to to that particular forwarding rule and see how it is dispersed to different instances. For that, let's just check the external IP first. So forwarding rules will describe the forbidden node, which tell us what the IP is. With the form. There is our IP. So let's just check our IP. Let's go there. Or we could also do a curl request. While curl, while true. While true. I guess we did some mistake somewhere. Um, let's see what happened. Let's just create another IP because some misconfiguration we did. So we'll just fix that by creating another basic check. We're redoing the whole process. Basically, we're creating a new static IP and then we're creating another HTTP health check. We're naming it differently. So right, okay, so we'll create another rule, yes. We'll name it www rule 1. And it's successfully created. We can view the external IP address of it. So let's first check if it's created successfully, and it is. And here's the IP of it. So let's do a curl request out there, and you can see it shows www2. Now let's do it once again. It's www3. So you have successfully set up a load balancer. Amazing. This was GCP, Google Cloud Platform. There's a lot of many more services provided by them. You can use Cloud Table to store data and BigQuery to manage large data sets and a lot more. Thank you guys. It was lovely to have you guys. If you have any doubts, please reach to us. I think yes.